going here? Let's make sure. Yeah. Okay. So now we're actually starting to get into what you've been learning all this factoring stuff up to, because basically it really hasn't had a purpose until we get to the solving quadratic equations. Now, you've never solved equations before because equations have to have equal signs. So you're just factoring, simplifying all that. But it does come in quite handy when we're working with equations, because equations mean we can actually find out an answer. Now, today we're going to spend a lot of time talking about the zero product law. Now, when something equals zero, okay, this has a very useful purpose for us in some of the units coming up and in 30-1. When something equals zero, zero is like the y value. Okay? Now I want you to think about a graph. When y equals zero, so even the line y equals zero, if you were to graph the line y equals 5, it goes straight across. The line y equals 0 would equal what? It's a word, there's a word for y equals 0. It is called the, so if you even look on your graph, so if you went to your calculator and just went to y equals, I just want you to put y equals 5 and hit zoom 6. That's y equals 5. What do you think y equals 0 is? The x-axis. So y equals 0 is the same thing as the x-axis. So just so you always know, when y equals 0, that's the x-axis. Yeah, I'll show you. So the x-axis, so this would be y equals 5. This would be y equals 4. This would be y equals 1. The x-axis would be y equals 0. They are the same thing. Okay? So that it is when y equals 0, when a number, when x, when we find the x value, that's going to be the same thing as a number on the x-axis. Okay, now you'll see right now, we have x minus 3 equals 0. What number would make that statement true? 3. Now, with our calculators back out, I just want you to hit y equals, and we're going to put that in, x minus 3. So you don't have to put in the 0, you just put in x minus 3. And then graph it. Where does it go through the x-axis? 3. So, when y equals 0, what's x? 3 in this graph. Okay? So that's a way you can always check these too. And here's a way to be able to check them. I showed the class. I'll do it quick now, and then in about 10 seconds I'll do it slow. So you hit to find where it's going through. Now you're looking at it going, yeah, it's a little obvious. It's 3. But what if it was 2.9 or 2.98? It might not be 3. So you go like this. You go second. Just watch first. Someone watch. Look it up. Look it up. Second. Trace. You go to 0, which is 2. Everyone's looking up. I'll go through it again, I promise. Just want you to watch. Then I press enter. Now see the spider? You always get to the left side of the x-intercept. You could be anywhere in here as long as you're to the left side. And it'll put an arrow up top when you put an enter. Then you move the spider to the right side of the x-intercept. Enter. Then you hit enter again, and it'll give you the 0 or the x-intercept down at the bottom there. Okay? No, that is when you have 2 lines. Now, since you bring that up, I could do this. y2 equals 0. And I will make it quite dark. Now, y2 equals 0 is the same thing as the x-axis. So now I have 2 lines, so I could do it your way by going second. I can now do intersect, enter, enter, enter. And it will give me the same answer. So if you're not going to use two lines, you have to use the zero way. If you want to put y equals 0 and then your other one, you can use the intersect way. Okay, it's a good question. I actually didn't do that in the last class. So this is the way I'm going to do it again without. Okay, so there's that way to do it, which I actually prefer that way. It's faster. But you have to put that second one in all the time. And you could maybe always leave that as y1 if you want. And then y2, y3. But this is how you do it with if you're just finding the 0. And remember, the 0 means the x-intercept. That's what it means, okay? So anyway, you go second, trace. What do I do next? 2. Then I get to the left side of it. Hit enter. Get to the right side of the x-intercept. Hit enter, and then enter again. Okay. Y-intercept is the easiest, actually. You just hit trace 0. Because when when x equals 0, that's always the y-intercept. So trace 0, enter. Okay? If you need help with that, I can help you later. But I'm just showing you there's a way you can really always check your answers. So just remember that the 0 is the same thing as the x-intercept. They mean the same thing. See, we're going to be finding zeros today. Those are things that make this equal 0. Now, in the second statement, what would you say would be the correct answer? X plus 1 equals 0. Negative 1. In the statement, x minus 3 times x plus 1 equals 0, what would x have to be to make that entire statement equal 0? Okay, good. 3 and negative 1. Okay? Now, the reason is, see, if you put 3 in here. Now, this equals 4, right? But who cares? What does the other one equal? 0. 0 times 4 will give you 0. So if you had this question on a test, 4 times 2 times 8 times 6 times 3 times 2 times 7 times 5 times 0 equals, okay, don't waste your time putting in 4 times 2 times 8 times 6 times 3 times 2, because what's the answer going to be? 0. Okay? So if 0's anywhere in multiplication, everything equals 0. So that's the time that this would equal 0. Or if you put a negative 1 in here. Now you're saying, well, but that doesn't equal 0. Who cares? One of them equals 0, so it will all equal 0 when you multiply it. So when does this thing equal 0? At 3 and negative 1. Okay? Now, the next one. When would that statement be true? When does x times x plus 1 equal 0? When x equals... Let's go left to right. There's an x in there. What would make that all equal 0? 0. And what's the other one? Negative 1. Okay. So basically, this is the zero product law. If a times b equals 0, then a must equal 0 or b equals 0. Or both, actually. Both could equal 0. Sometimes that happens. X plus 1 times x plus 1, right? Negative 1 would make them both 0. That can happen. Okay, now let's just do some of these quick. Now let's see if we can do it by just looking at it. What would make that statement true? X would have to equal 0. How about the next one? X would equal negative 2 or 7. C. Let's go left to right all the time. 0, negative 2, and plus 7. Good. How about D? No. Because 0 actually, I'm going to do that. See, 2 times 0 is 0 plus 1. This would equal 1 here, wouldn't it? 3 times 0 minus 2, this would equal negative 2. So this would equal negative 2. So 0 is not one of them that works. Negative 2. That would make that negative 3 in here. Okay, we want to make the inside of that 1 equals 0. One half, negative 1/2 would work. And sorry? 2/3. Okay, now at this point you're going, what? I never get that. I don't know what's even going on. I'll show you how to do that. Now you can separate these because if the 1 equals 0, it's all going to equal 0. So I kind of like, you separate it. So the first one, well, when does 2x plus 1 equal 0? Then you just do some algebra. Minus 1 minus 1. 2x equals negative 1. Then you divide by 2 when x equals negative 1/2. I just did simple algebra. Subtracted 1 to both sides, divided by 2. No? Oh, I don't pull it out. Some smart guy made it up, and I just do it. 3x minus 2 equals 0. I would add 2. 3x equals 2, and then divide by 3. X equals 2/3. So you can algebraically do it all the time, but after a while you can start to see the pattern. And one person in the other class said, can you just do this all the time? And I said, yeah, you can. But that's something you figured out, kind of a trick. And you'll see these after a while, that it's kind of like if you bring the, so if it was 3x minus 2 equals 0, you kind of, all you have to do is bring this under here and then switch the sign. That would be the answer. So that would be positive 2/3. The other one would be negative 1/2. That's a trick though, right? And the bad thing about tricks, some people miss one little part of it and do their whole exam with it. So remember, every so often I would just do it algebraically to make sure my so-called trick is working, because you don't want to do that for a whole test. Okay, so we're going to go right to example right here. Example 2. And we're going to use the zero product law. Now, it is not a bad thing to know the answer before you get to these, before you do all the work. And some people, I know, especially in the, back like 10 years ago, was it like show your work, yeah, show your work, I don't care, right? Some people could look at A and just get the answer without any work. And as a teacher, you always have to be, there's some that you're going to need to do some work, right? But if you don't show any work, I would always talk to that student. I go, how come you didn't show any work here? You just have the answer. And if they're like, oh, I just do that one in their head, I give them a couple more and they can do it in their head. Then I'm like, okay, you can't do it in your head. But did you look over someone's shoulder or can you do it in your head? That's always the question. Okay? Now, in A, some people could do this one without. What would it be? There's 2 of them. So some people wouldn't be able to do it without. And negative 9. Okay? So if someone just had that down, I wouldn't go, for that one, I would hope that some people could do that in their head. Because 9 squared minus 81 is 0, and negative 9 squared is 81. Remember, you always have to substitute with brackets. Is still 0. But here's how we would do it algebraically. Now, x squared minus 81, what do you notice about that? Perfect. All right, it's difference of squares, right? Difference of perfect squares. So what does that factor out to be? X minus 9, x plus 9 equals 0. So what does x equal? 9 and negative 9. Okay? B. Anyone do that one in their head? Okay, so let's do some work. What do I notice about this one? Also difference of squares. So this would be 2x minus 3. 2x plus 3 equals 0. Now make sure we're always writing equals 0. So what would you say x equals to make this thing true? 3 over 2 and negative 3 over 2. Now watch, it can also be written like this. I know the book does this a lot, just makes it faster, but means the same thing. Okay, C. Good boy. What'd you take out? Okay, what's inside? X minus 9 equals 0. So what can x equal? Left or right, you guys? The first one would be? No, not 10. 3. 0. Because 10 times 0 is 0. 0 times all that stuff inside? 0. Okay. What's the other one that would make this thing all equal 0? 9. Right. Because 0 makes that all equal 0 and that, right? Are you with me here, you guys? You guys breathing out there? You guys are like camera shy or something. Next one. Take out a 10, leave me with x squared minus 9 equals 0. Yeah, so that's x minus 3, x plus 3 equals 0. X equals? No, not this time. Now, can always get one person in every class. 3 and negative 3. There's no place 0 would make that thing equal 0. Try it out if you have any spare time. Yes, you do. Next one. Okay, let's start moving it up a bit. Make it a little harder. Yep. We're going to do the thing. That equals negative 13 and multiply to equal negative 30. What would the signs be? Negative, positive. Okay, what are they? That's the other one everyone grabs. Josh, it's not negative 3 and 10. Now the whole world knows that. What would be, what is it? Negative 15 and 2. Okay. Yes, good job, Kelsey. Isn't it Miss Gritter to us? Okay, 3x squared minus 15x plus 2x minus 10 equals 0. Isn't it weird that all this is on YouTube, Miss Gritter? Okay, lots of people are away today too. So. Okay, grouping. What can I take out of the first set? 3x, leaving me with x minus 5. Next group, 2x minus 5. So I've got x minus 5, 3, x minus 5, and 3x plus 2 equals 0. What are my two answers? X equals 5 and negative 2 over 3. I thought that's what you said, Justin. Okay, now this one is a good one because this is how kind of actually most things end up, and it's kind of like, well, if you look at all the ones we've been doing up to now, they always equal 0, equal 0, equal 0. So keep going with that. This one, we're going to bring the 25 over the other side. So we're going to add 25 to both sides. Then I can GCF. And then I can take out a 5, leaving me with x squared plus 6x plus 5 equals 0. So this would be, I need two things that add to give me 6, multiply to give me 5. 3 and 2. So we got 5 x plus 3. Oops, it's not 3 and 2. So 3 times 2 is not 5. Can't believe you did that, Andrew. Who was it then? Oh, sorry, Andrew. That was Justin. Okay, YouTube, that was Justin. Repeat. Sorry, Andrew. Okay, what are my numbers? 5 and 1, right? So I've got x plus 5, x plus 1. Okay, therefore what does x equal? -5 and -1. Okay, so let's just stop things for a second here. How do I know this is right? And that's what this entire unit, if you gave me time on my test, I would be able to make sure I got every single one right. Okay, so it's one thing to know how to do them. I got to get the answers. But let's assume everyone in here knows what they're doing, but we all make mistakes. I can catch them now. How can I catch if I got this right, I got this wrong? Who knows? Great, and you should get the answer. The other one, and let's try this one out because I want you to see, like all of them work, of course, but we're just going to put in this one. Put in the, not the original, because you can't. Everything has to be on the one side. So our first line, put in 5x squared plus 30x plus 25. So you can't put in the original question because it doesn't all equal. It's all going to be on the one side. And then if we hit zoom 6, we're all looking at the same graph. It should be going through -5 and -1. Okay, so here's -5, there's -1. I'm like, okay, good to go. Not at the same time, but if you do, and if I put in my y2, sorry, as 0, then I can use my intersect, right? And you won't even see it if you don't do the thick line, because it did it already. You don't even see it, but it went right over the x. So then I go second, trace, 5, enter, 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 and it'll go to that one. Now, to get to the other one, you have to go second, trace, 5, and then move the spider. Sometimes you'll move the spider first and do it, and you'll waste your time, because it'll still go back. Okay, so it gives you the answers right there. So with enough time, you can get you can check your answers with the calculator. Okay, trace 5, right? Yeah, did you do y2 is 0? Yeah, enter, enter, enter. Should give second trace. Okay, now let's do a couple questions that would deal with this same kind of concept, and you can figure out some geometry problems with it. Okay, so this is a rectangular sheet of paper. So if you're a highly visual person like I am, I'm going to draw a rectangle. You just use your smart board right here. Oh yeah, that's right. That's what happens. Now, the area of this, you can just put in the middle. That's 300 centimeters squared. Now it says the length is 5 more than the width. Now we want to do a variable. Should we call the length the x or the width the x? Why though? The mic didn't pick that up. We'll just pretend. I won't repeat that. I don't want to embarrass you. Why would, like what? I mean, here's width, okay? Here's length. What would we call x? We have a choice. Because it's horizontal, that's why you pick it. He's very adamant about that. So x is the length because it's horizontal. Oh, okay. I'm gonna just ask you a question here. If your length is x, Sam, what would your width be? No, no, we can only have one variable, and we know that the length is 5 more than the width. Hmm? So your width would be x minus 5. Okay. If we made the width x, what would the length be? Okay. So if you make this x, this would be x plus 5. The other way would work. It's not wrong. You could do x and x minus 5, you get the same answer. It's not 5 times, it's 5 more. If you have 5 more dollars than me, you don't have 5 times what I have. Unless I had a dollar. I said it first. Yes? You said because x is fatter, so that's length. That makes it wrong. No, you didn't. You said x is fatter. It was your reasoning, I think, that was a little bit whacked out. Okay. Now, how do you figure out area? Length times width. So we would have x times x plus 5 equals 300. Now, actually, we don't even know what we're looking for. What are we looking for after all this is done? The perimeter. So once we find the sides, we're going to have to add them all up. But let's find the sides first. We don't know what they are. So now we're going to make it into a polynomial that equals 0. So we got x squared plus 5x. I'm going to bring the 300 to this side. Minus 300 equals 0. Now I can solve for it. Okay, now, if this was a multiple choice question, I might just put this in my calculator. Find the x-intercept. Okay, but let's pretend that this one is a written response. So what would I do? I'm looking for two things that add to 5 and multiply to give me negative 300, right? What are those numbers? No, positive and a negative, right? Okay, what are they? 20 and negative 15, right? So that would be x plus 20, x minus 15 equals 0. Therefore, x equals negative 20 and 15. So we got two answers. Sometimes you will get two answers. Sometimes both of them are right. Sometimes one of them is right. Sometimes none of them are right. You need to go back to your original to see, is negative 20 a possibility? What step did I miss? You don't have to cut it up. This is a type 1. You don't have to do any grouping. You just pick those two numbers and put them in, 20 and negative 15. Aw, you okay? Someone give him a hug. Not Josh. Not Josh. Okay. There's just so much to remember. Okay, Josh, remember? I need to get through this. Everybody loves Sam. What? Guys, what are my, if I put negative 20 in, what would be my dimensions? Can you put negative 20 in? No. This, so, can't have negative dimensions, right? Okay, now, therefore, what are my dimensions then? So my dimensions would be 15 by 20, right? X plus 5. This is x plus 5. So therefore, what is my perimeter? That's area. No. 2 times 15 plus 2 times 20. 70, yes. Okay, guys, we're ready to go? Okay. One more here. This diagram shows basically it's a rhombus, but it's actually even nicer than that because it is the right and left triangles are the same. Now, it says we want to try and label as much as possible on this before we get going because we have 2 triangles, 1, 2, and then we have a rectangle. So if we added 1 plus 2 plus 3, we would get the entire area. Now, how do we find, first of all, is there any angles we would know or any sides that we would know? Okay, this is 45. This would be 45 because of the 90s. Now that tells us something about the triangle. It's not equilateral because that's a 60, 60, 60. Isosceles. Isosceles have a right isosceles. That means, what other side do you see how these two would be the same? Okay? Therefore, these two would be the same. This is an isosceles triangle here, coming off here. Now, here's what I need to know. I know now that that's x times x, because divided by 2. 1/2 AB for that triangle, 1/2 AB for the other, okay? This is 1/2 AB to find this triangle. This is 1/2 AB to find this triangle. Now this triangle would be length times width. Now I know that my width is x already. What would this length of this rectangle be? Now putting up your hand, I don't want you to yell this one out. What would be the length of that line? Yep. Excellent. Because 36 is the entire thing. 36 minus x minus x. So this line here would be 36 minus 2x. So the area, it says, we'll show that the area is this. So sometimes it gives us the answer and you have to show it. And you're going, oh, that's easy to give me the answer. I'm going to get this for sure. Okay, but after some students have spent like 20 minutes on it, they still can't get it. Therefore, they've given up that question. So you have 2 triangles plus the 1 rectangle. Now 2 triangles is 2 times 1/2 AB, and a rectangle is length times width. Now the 2 times 1/2 actually cancel each other. So it's just AB. Now in my diagram, what is A? Look at my diagram. What's the altitude of that triangle? X. What is the base of the triangle? X. Okay? Plus, what's the length of the 36 minus 2x and the width? X. Okay? So, this is x squared plus 36x minus 2x squared. All I did was distribute this x in here. I'm just getting everything together. Now see how I've got an x squared here and a negative 2x squared? I could combine that, so that would be 36 minus x squared. It's not, oh, it actually is a difference of squares, but it wanted me to do this. So what could I do to make it look like that? Oh, it's not difference of squares, sorry, because I forgot the 36x. I'm like, yeah, I never saw that last time. Okay, so what can I do to make it look like that thing up there? Take an x out, leaving me with 36 minus x. Okay. They gave us the answer. I had to come up with it. Okay, now if it says find the value of x. So that's not too bad. X times 36 minus x has to equal 260. Because I found the area formula. has to equal 260. So we want to get everything on the left or on one side. Doesn't always have to be on the left. But this would be 36x minus x squared minus 260. Actually, let's put equal 260. I just got rid of my x. I got my x in. Because you know what? I want to get everything on the right. I want to get everything on the right because then my x squared is positive. So I would have 0 equals x squared minus 36x plus 260. So I put everything on the right, so I would not have a negative x squared. No, 260 was on the right already. So it's staying there. Right. Divide everything by -1, yep. Give you one more step though. I'm a busy guy. Places to go, people to see. Okay, I need two things that add to give me -36 and multiply to give me 260. Okay, are they both negative, both positive, one negative, one? They got to be both negative. (26 and 10). Good. Okay, so x minus 26, x minus 10. Now remember, I can go right to that because that is not a type 2 where I'm grouping. There's nothing in front of the x squared. So x equals 26 or 10. Now again, it could be both of them. It could be one of them. It could be none of them. Okay? Now, this one's extra tricky because the 26, it does that work. If you put in 26 times 0.36, it does work when you put it in there. Where it doesn't work is if I put it into here. Just to find the length of that, 36 minus 2x, would that work? So it actually fails here. So this is kind of a mean question, but this doesn't work. No, because for the length, that's 36 minus 2x. 36 minus 2 times 26, that equals, I think I even did the math, that equals -16. So that's not possible. Okay, so that one's pretty mean because most people wouldn't check that. They would just, so x equals 10. No, I would never do that on a test. Too nice a guy. So 1 to 3 do the odds, and 4, 5, and 7. Okay, so you have an opportunity for every one of you to finish your homework. Let's get right to it. And